In this question, we are given that L of xy is the local linear approximation of the function f of xy at 2 comma 1, and we are also given some initial values, that is g of 2 comma 1, gx of 2 comma 1, gy of 2 comma 1, and using these initial values, we have to determine this L of 3 comma 2. So for this, I'm going to use this linearization formula, which says that L of xy is approximately equal to f of a comma b plus fx of a comma b. This fx is the partial derivative of the function with respect to x times x minus a plus fy at a comma b. This is the partial derivative of the function with respect to y times y minus b. So first, let's determine this equation for L of xy using the function f of xy as well as this point 2 comma 1. So we can consider this 2 comma 1 as a comma b. So let me write the linearization equation, that is L of x comma y. This is approximately equal to f of a comma b. So therefore, this will become, since a equal to 2 and b equal to 1, this will become f of 2 comma 1 plus fx of a comma b, that is fx of 2 comma 1 times x minus a, that is x minus 2, since a is 2, plus fy, which is the partial derivative of function with respect to y at 2 comma 1 times y minus b is 1, so it becomes y minus 1. So let's consider this equation as equation number 1. So to determine L of 3 comma 1, 3 comma 2, basically we have to determine this first. So this is the equation. So let's determine this f of 2 comma 1, and then we have to determine the partial derivative at 2 comma 1, partial derivative of function with respect to y at 2 comma 1. Substitute these values into this equation. So then we will get L of x comma y. And finally, we just have to substitute x equal to 3 and y equal to 2 to determine this L of 3 comma 2. So first, I'm going to find f of 2 comma 1 by substituting x equal to 2 and y equal to 1 into the given function f of x comma y. So let me first copy the f of x comma y. This is f of x comma y. This equals x squared plus 2y cube plus g of x comma y divided by x. Now let's evaluate this function at 2 comma 1 by plugging x equal to 2 and y equal to 1. So therefore this will become f of 2 comma 1, and this equals, we replace x by 2. So therefore this become 2 squared plus 2 times of y is replaced as 1. So it becomes 1 cube plus g of x comma y. So it becomes g of 2 comma 1 divided by x is 2. So let's evaluate this, and this equals 2 square is 4 plus 1 cube is 1, 1 times of 2 is 2 plus g of 2 comma 1. We're already given the g of 2 comma 1, which is 4. So I plug in 4 and then divided by 2. So this the value of this is 6 plus 4 divided by 2 is 2. So 6 plus 2 equals 8. So we have determined that f of 2 comma 1, this equals 8. Now we will evaluate this fx of 2 comma 1. For this, we need to differentiate this f of x comma y partially with respect to x. So I'm going to differentiate this function f of x comma y partially with respect to x. So I write this as fx of x comma y, and this equals derivative of x squared is 2x, and then this 2y cube, since we differentiate partially with respect to x, this is a constant, so it becomes 0. And then we have to differentiate this quotient, that is g of xy divided by x with respect to x. So here I'm going to apply the quotient rule. So first I consider x and then differentiate g of xy with respect to x, which is gx of x comma y minus I put this g of x comma y and then differentiate x with respect to x, which is 1. This is all divided by x squared, that is the denominator squared. So this is according to the quotient rule. Now we will evaluate fx of 2 comma 1 by replacing x equal to 2 and y equal to 1 into this equation. So therefore this becomes fx of 2 comma 1, and this equals 2 times of 2 plus we replace x by 2, so therefore this becomes 2, and then this becomes gx of 2 comma 1 minus g of 2 comma 1, because 1 times of g of xy is g of xy only. This is divided by x is 2, so therefore this becomes 2 squared. Now let's simplify this. This becomes 2 times of 2 is 4, and then we have 2 times of gx of 2 comma 1. We see that it is equal to 4. So I'm going to replace 4 here minus g of 2 comma 1, and that is also 4. So I replace 4 here. Divided by 2 square is 4. So let's evaluate this. So this is 4 plus 2 times of 4 is 8, and then 8 minus 4 is 4. So we then have 4 divided by 4, and this equals 1. So we get 4 plus 1 equals 4, 5. So therefore, we see that fx of 2 comma 1, which is the partial derivative of the function f of xy with respect to x at the point 2 comma 1, and this equals 5. Now we will determine this for value, that is fy of 2 comma 1. So for this we have to differentiate f of x comma y partially with respect to y. So I'm going to do that. So therefore this becomes fy of x comma y, and this equals we have x squared, so it is independent of y. We treat this as constant, so therefore if you take the derivative of constant it becomes 0, and then derivative of 2y cube we apply the power rule, so therefore it becomes 2 times of derivative of y cube is 3y squared. So basically this equals 2 times 3 is 6, so I can put this as 6y squared. This is 6y squared. Now we find the derivative of the last term, that is this quotient g of x comma y over x. Since x is treated as a constant, I can rewrite this as 1 by x times the derivative of g of xy with respect to y, which is gy of x comma y. Now let's evaluate this function at point 2 comma 1. So I'm going to replace x equal to 2 and y equal to 1 into this equation. So therefore we get fy of 2 comma 1. So this equals 6 times of y is replaced as 1. It becomes 6 times of 1 square plus 1 divided by x is 2. So I put 1 by 2. Then this becomes gy of 2 comma 1. We will replace the value gy of 2 comma 1, and this is given as 6. So I'm going to replace this as 6. This is replaced as 6 gy of 2 comma 1. So it becomes like this. Now let's evaluate this. This is 6 times of 1 square is 6, plus I can do this cancellation. This goes 3 times. So 6 plus 3 equals 9. So we can now see that fy of 2 comma 1, and this equals 9. So now that we have determined the values of f of 2 comma 1, fx of 2 comma 1, and fy of 2 comma 1, we can substitute these values into this equation to write the equation for L of xy. So I write down L of xy, and this is approximately equal to f of 2 comma 1 is replaced as 8. This is 8 plus fx of 2 comma 1. This equals 5. So therefore it becomes 5 times of x minus 2 plus fy of 2 comma 1, which is replaced as 9, and 9 times of y minus 1. We can simplify this equation. So L of x comma y, this is approximately equal to, we will do the distribution, that is we have 8 plus 5 times of x is 5x, 5 times of negative 2 is negative 10, plus 9 times of y is 9y minus 9. So we will have 5x. So I write down L of xy. This is approximately equal to 5x plus 9y. We then have 8 minus 10 is minus 2. Minus 2 and minus 9 is minus 11. And so this is the equation for linear approximation, that is L of x comma y. This is equal to 5x plus 9y minus 11. So now using this equation, we can determine this L of 3 comma 2 by replacing x by 3 and y by 2 into this equation. So we get L of x comma y. I'm sorry, this has to be 3 comma 2. If we replace x by 3, so this is L of 3 comma 2. This equals 5 times of x is 3 plus y is replaced as 2. So it becomes 9 times of 2 minus 11. And this equals 5 times of 3 is 15 plus 9 times 2 is 18 minus 11. So this equals 15 minus 11 and this equals 4. 18 plus 4 is 22. So therefore the approximate value of L of 3 comma 2, this equals 22.